To show that these points are the vertices of a right triangle, there are two different options. We can either draw a picture and check the slopes of each one of the line segments, or we could use the Pythagorean theorem. I think the slope argument is going to be the easiest to use here. So let's first of all draw a sketch of these points. It doesn't have to be accurate. Point A is at 2, 1. Point B is at 4, 0. So this is point B, and this is point A. And C is at 5, 7. So 5, 7 is going to be up here somewhere. So this is the triangle we're dealing with, and I wanted to like to show that that is a right triangle. So let's find the three slopes. If I find the slope of the line segment AB, we get, remember, the slope is the change in y divided by the change in x. So the slope AB is 1 minus 0 divided by 2 minus 4. And that's 1 divided by negative 2, or negative 1/2. If we look at the slope from A to C, again, to take change in y divided by change in x, I can take 1 minus 7 divided by 2 minus 5. And I get 1 minus 7 is negative 6 divided by negative 3. So that slope is 2. And let's find the third slope. The slope of BC is going to be 0 minus 7 divided by 4 minus 5, which is going to be 7 divided by negative 7 divided by negative 1 is 7. Now if we look at these slopes, these two slopes are negative reciprocals of one another. One of the slopes, 2, is the negative reciprocal of minus 1/2. So in fact, AB and AC are perpendicular to each other. So this must be a right angle, despite the sloppiness of the picture. That has to be a right angle. The slopes are negative reciprocals. Let's notice the other thing we could have done is to use the Pythagorean theorem. We could have found this distance, and that distance, and that distance, and checked that they satisfy the Pythagorean theorem.